right, so number 5 has a really interesting question. It says, hey, what's the limit as x goes to 0 of 1 over h of the integral of x to x plus h? This is interesting, of this function. So remember, it looks like this. Limit as x goes to 0 of, and I'm going to change it, x to x plus h over, let's call this f of x over h. And if you remember, the derivative, definition of derivative was the limit as h goes to 0, of f of x plus h minus f of x over h. So this is starting to look like the derivative, except it has the integral put in it. So if we rewrite it, the limit as h goes to 0, we replace h with x, then we can see that we can take the integral and basically take the limit part and call that the derivative. So here I'm trying to show you that x plus h, this right here, this integral, isn't that equal to f of x plus h minus f of x over h? And then you have this limit out here. So I guess I should include that. You have this limit out here, and all of a sudden that's the derivative. And so it's saying, hey, this really means to take the derivative of the integral. And so your function was e to the t minus 1 to the 1/2. So you would make that the derivative of e to the t minus, of the integral of e to the t minus 1/2. So you just get, it's another way to do the fundamental theorem of calculus. You just get what you had with the x put in instead of the t. I rewrote it as a square root, I guess. I don't know if it was rewritten. How did it show up? Yeah, it started as a square root. So it's sort of weird, but if you see this limit, and then it looks like the definition, you have this x and x plus h. It's a little tricky, but you'll see another one, and I bet you'll be able to pull it out when you see the next one, or one similar. All right, we have another example where they tell you what they want u to be. So they say, hey, let u be this. And so you say, okay, I'll let u equal the square root of x minus 2. And then if you look at what you get, you don't have something, you need to get rid of this, right, you guys? So you need to have it in terms of x. But do you really want to say that, well, I guess you can, you're solving for x, so you would just go u squared equals x minus 2, and so x is u squared minus 2 right here. So now here's the difference though. Instead of trying to take the derivative of that, I'm going to take the derivative of this u squared, because we're just doing implicit to both sides, right? So 2u du would equal dx. So that's just a little different, and a little trick they showed you. Now we've solved for u, and this is a definite integral, so you have to change. So you made u the square root of x minus 2. So the square root of, it started out of 6 minus 2 is the square root of 4, which is 2. So I end up with a 2 as one of my ends. And then I had a 3, and so the square root of 3 minus 2 is 1, so you end up with 1. And now let's go back up here to see what we got when we put back in what we needed to. We said that x was equal to u squared plus 2, so that was our old x, and we made u equal to that square root. So we end up with this function, and if you multiply it out, you have to put the what did dx become? It was 2u du. So you have u squared plus 2u times 2u du, which is 2u squared times u squared plus 2. If you multiply that out, you get 2u to the 4th plus 4u squared from 1 to 2 du. And they don't ask you to solve it,
I just factored out a 2, and I got 2 of the integral u to the 4th plus 2u squared du. Now, to be fair, I would never have done it that way. This is what they told you had to make u. There's no way. I would have let u equal x minus 2. And then I would have had u to the 1/2 as under behind my integral. Alexa, stop. So I have to change these again. Now, these don't change the same way if I made u x minus 2. You can make it, it would be 6 minus 2, which is 4, and 3 minus 2, which is 1. And I made x equal u plus 2, so that was my x. And then this was the square root of x minus 2, which I made u to the 1/2. They don't want us to solve it. It would be 1 to 4, and then multiply that through u to the 3/2 plus 2u to the 1/2. So that was example 6. I'll stop there.